Good day, everyone. Today I'm going to teach about trigonometric identities. In this particular video, I'll just deal with the teachings, and in the next video, we'll deal with specific exercises. We'll deal with a lot of exercises, matter of fact. And just before I continue, don't forget to like the video and subscribe to my channel. So here are the basic things you need to know. Probably most of you know it. So whenever we see sine theta over cos theta, this becomes tan theta. Similarly, when you see tan, you can actually go backwards, right? So when you see tan, you can actually change it to sine theta over cos theta. So whatever will give you, just know we work forwards and backwards. And here is the next one to remember. Whenever we see sine squared x, or rather sine squared theta, plus cos squared theta, this gives you 1. And notice sine over cos is tan theta, so also sine squared theta over cos squared theta gives us tan squared theta. So it works for the squares as well as the ones that are not squared. So sine theta over cos theta is tan theta, and sine squared over cos squared is tan squared theta. So these are the basic things to cram. Before I add 2 more, just remember sine squared plus cos squared is 1, but sine theta plus cos theta is not equals to 1, right? Don't make it equals to 1, right? Only sine squared plus cos squared is equals to 1, but sine theta plus cos theta is not equals to 1. It's not an identity, right? There are cases where it's equals to 1, but it's not an identity, so please don't confuse them. Sine squared plus cos squared is 1, but sine plus cos is not 1, right? It's not an identity. So let me add 2 more. Whenever you see sine squared theta, we can actually change it to 1 minus cos squared theta. Similarly, when you see 1 minus cos squared theta, you can actually reverse it into sine squared theta, right? Similarly, when we have cos squared theta, this is 1 minus sine squared theta. So just before I do some exercises, I want you to cram this thing. So just make sure you cram this thing. We're going to work on it. So you can just pause the video and cram this thing before we continue. And let's begin. By the way, before I continue, I have to show you 2 things, right? 2 things that you have to know how to do. So you have to know how to add fractions. For instance, if we have this 2, right, we're going to apply it in trigonometry. But when we have this 2, what you do first is you multiply the denominators and you will have xy. Then you cross multiply. So you'll say 2 times y, which is 2y, plus 3 times x, which is 3x. This skill is going to be used a lot, right? So whenever you have fractions, adding or subtracting, never say you're stuck. You cannot be stuck with fractions, adding or subtracting. And always remember, whenever you cross multiply, always start with the numerator that comes first. So let's apply this to trig. So let's look at this, for instance. If we have these are fractions adding, we can never be stuck. So what you do is you multiply the denominator. So we'll have sine theta cos theta, right? X times y is xy, so sine times cos is sine cos. And then now you cross multiply, so this will be cos squared theta, plus you cross, then that will be sine squared theta. Now notice sine squared theta plus cos squared theta is 1, right? The order doesn't matter actually. This still gives you 1. So this is equals to 1 over sine theta cos theta. And here is another example. These are not necessarily examples that I picked from past papers as yet, right? This I'm just showing you how to apply the skill. So sometimes you can have this and you would think that you're not adding fractions. You are still adding fractions, right? A fraction times a number, let's just, it's in that form. It's similar to 2 over 3 plus 4, right? This is still additional fractions because sine is the same as sine over 1, you see? So then we apply the skill again. 1 times sine, of course, is sine. Then cos times 1 is cos theta. Then that becomes sine squared theta. Right? So I'm going to end here with this part just for now. Of course, I can turn this, or let's just do that. These are not examples I picked, they're just random examples that I set. So this becomes 1 minus cos squared theta, because we changed sine squared into cos, and then now this is over sine theta. And check, look at this. It actually checks out. This and this cancels out. because cos minus cos is 0, and we're left with 1 minus 1 over sine theta. So there we have it. So this skill is applicable. This is just something that I randomly set, right? Another skill you must know. So another skill that you must know is the multiplication of fractions. So for instance, if we have something like this, what you do is whenever something is the same but on different lines, for instance, this is a new this are the same but one is a numerator, the other one is a denominator. So when something is the same but one is a numerator and the other one is a denominator, you just cancel them out and it leaves 1. Similarly, cos squared and cos squared are the same, so you just cancel them out and you leave 1 1. One more example of this, and before that example, when we cancel out, then we'll multiply them. So 1 times 1 is just 1, because it cancels and it leaves 1, right? So 1 times 1 is 1, 1 times 1 is 1, so 1 over 1, which will still give us 1. Another example is this. So I'm giving you important skills that we'll use to apply in some exercises. So when we look at this stuff, we see that this is the same as this, except that this is squared and this is not squared. So what happens is that this cancels, and it cancels one of them, so it leaves 1, right? Because sine squared is the same as sine times sine, right? If I expand it, it's the same as sine times sine over cos. So what happens here basically is this just cancels with one of them and leaves the other one. So whenever you see sine squared, it just cancels with one of them, right? Another example of this, and before that example, let's just multiply what's left. So we'll be left with, so it cancels and leaves 1, and then now we'll be left with sine theta times 1, which is sine theta, and then cos theta times 1, which is cos theta. Then sine over cos, well, you know it, tan theta. So always check if it's possible for your staff to move forward, and of course from here we can move forward. Here is another example. You can even attempt this. You can even pause the video and attempt it if you want to. So let's look at this. So what happens here is this will cancel with one of them, so it will be left 2. Then there's nothing to cancel out there, right? So now what we're left with is sine squared theta here. So sine squared, and then down here we're left with 1. Sine squared theta times 1 is sine squared theta, and then now we have over cos theta. Of course, we could change this into 1 minus cos squared theta, but then it's not really going to help us, right? It's not really going to help us. Besides, this is just my own example. I'm just showing you the skills of cross multiplying. There are some places where this thing will be useful. Here is another example. So when we have this will cancel with 2 of them and leave 3 of them, right? Then we'll have sine cubed, this is going to be 1 left, and here's now left sine cubed theta. So this is going to be sine cubed theta times 1 is still sine cubed theta, right? And then all over cos theta times 1 is just cos theta. And there we have it. So let me show you the last skill before we go to exercises. So another skill is the tip and times method. So this is division of fractions. So when you do it step by step, whenever you see this, this is the same as cos theta over sine theta. This is divided by, right? Whenever we have a fraction divided by another fraction, what you do is you leave the first one undone, right? And then you change the division sign into multiplication, then you just switch the next one. So whatever is done will go on top, whatever is on top will go down. So this will become cos theta over sine theta, right? See, what was down went on top, what was on top went down, and then from there now you multiply them. So cos times cos is cos squared. Of course, there's nothing to cancel, right? Yes, they are the same, but they're not in different lines, so we cannot cancel them out. So then this is cos squared theta over sine squared theta. This is not equal to tan squared, right? Sine squared over cos squared is tan squared, but then now cos squared over sine squared, it should be 1 over tan theta. You can just cram that as well. And then now let me show you another example. So sometimes we can have something like this. This is still division of fractions. It's basically sine divided by this stuff. So what you do is sine is the same as sine over 1, right? Then you change the division sign into multiplication. Then we switch the second fraction. So this is cos over sine. and voila, look at this, they cancel out because they're the same but on different lines, and then we left with 1. Your answer basically will be cos over 1, which is still cos theta. And let me show you one last example. So remember the skill, you can always repeat this video and just attempt them, it's vital. So here is another one. So we have a fraction divided by cos, which is still the same as a fraction divided by a fraction. Remember, whenever we have something only, we can just make it over 1, right? So this is the same as over 1. So what you do here is that you change, you'll actually repeat the first one as it is again. So we'll say sine. We always repeat the first one and we switch the second fraction. So this will become 1 over cos instead of it being cos over 1. And then we change the division sign into multiplication. And check it out, this cancels out because they're the same, and it leaves 1, 1. So now 1 times 1 is 1, sine times 1 is sine. So the answer we're left with is 1 over sine. Alright, so here comes an exercise. So in this particular video I'm still teaching, right? And then in the other video we'll just deal strictly with exercises. Alright, and I can put it in the link of the description below, right? So in the description below you'll find the link of the video. So when you see this stuff, this is cos times tan, right? So when you look at this, there's nothing there to change, but when you look at the bottom, usually when we see tan, we always change tan, right? So whenever you see tan, have a consciousness of turning it into sine over cos. So this becomes 2 sine x all over cos x times sine over cos. Now when you deal with this part alone, you'd notice that this is multiplication of fractions, so this is the same as over 1, and these two cancels because one is a numerator, the other one is a denominator, and then what you're left with is 2 sine x over sine x, and then this 2 cancels out and we left with our answer as 2. So this was simple, we just had to change tan. Once we changed tan, it was now a multiplication of fractions. And then when we cancel out, we're left with sine x, right? Because it was sine x over 1, which is still sine x. And of course, this and this cancels, right? Whenever we have got something like 2x over x, the x's cancel, and we're left with 2. So sometimes when you cancel, rather sometimes when you change tan, it might be an additional fraction, it depends. For instance, if it was cos x plus tan x, we would of course change tan and we'll say cos x plus sine x over cos x, and this will not be an addition of fractions, and cos is the same as over 1. Then we would say cos times 1, which is still cos x, and then would multiply this stuff and it will become cos squared x, would multiply, then it becomes sine x, right? So this is just an example. So I'm not going to continue because it's just an example, right? So now here is another example. Here's another exercise. So here is another exercise, right? So what we could do here is that we could add fractions, right? Or we could just change this. Let's change tan. Remember, when you see tan, have the consciousness of turning it into sine over cos. So this is 2 over sine x. This becomes minus 2 cos x all over sine over cos. Now we cannot add fractions like this. Of course we can, but it will be more complicated. Now whenever we have a complex fraction, we have to make it simple on the side. So we have this stuff, right? So let's deal with it on the side. So this is gonna be 2 cos x over sine x over cos x. Now if you notice, it's just like having a number divided by a fraction, right? If we have a number divided by a fraction, this number is the same as the number over 1 divided by that fraction. So this is a fraction divided by a fraction, right? And if you don't understand something, you can always just go backwards in the video and check it again. So when we've got this stuff, this is the same as 2 cos x over 1 all divided by sine x over cos x. Now when we have this, remember this is 2 cos x over 1 times, right? We change the division into multiplication and we now say cos x over sine x. And then this becomes 2 cos squared x over sine x, because when you multiply, that's what we have. When you multiply the bottom, that's what we have, and there was nothing to cancel because yes, this cos is the same as this cos, but they're both numerators. So the result that we get is what we'll put there. So then this becomes 2 over sine x minus 2 cos squared x all over sine x, right? And then now when we're adding or subtracting fractions, now notice here we don't need to multiply the numerators because they are the same, right? The basic thing is whenever we have 2 over 5 plus 3 over 5, we don't need to multiply them. This just becomes 5. We just repeat it and then we just add the numerator. So this becomes 5. 5 over 5 is 1. So in this case, we're going to do the same thing. Since the denominators are the same, it means our answer contains the same denominator. Then we'll just subtract them. So it becomes 2 minus 2 cos squared x, right? And then how do we go further here? We can even change that, right? Or we can factorize. So if we factorize, the common factor here is 2. So whenever we factorize, this is going to become 1 minus cos squared x. And then this becomes over sine x. And when you look at this, 1 minus cos squared x is sine x, right? So this becomes sine squared x over sine x. Now what happens here is that this cancels with one of them, right? So now what we'll have is 2 sine x. Or if I explain it even more, here we had sine squared over sine, right? If I choose to expand this is actually going to be 2 sine x sine x, because sine squared is sine times sine, right? And then this is all over sine. You see, this cancels with one of them and it leaves 2 sine x, right? Let me show you another approach we could have done also from this level. So if you had chosen not to factorize, if you had chosen just to change this, if you change this, then it would be 2 minus 2. Cos will become 1 minus sine squared x, right? Over sine x. If you chose to do it this way, this was going to be 2 minus 2 minus sine squared x over sine x. And by the way, when we deal with the signs, this is a negative, this is a positive, right? So then if you notice, these two will cancel out and it will be left 2 sine squared x over sine x. Gives us the same answer. This becomes 2 sine x. So always remember, when you see something similar, you can see these are not like terms, but if you see something similar appearing in both terms, you can just factor it out. Or if you like, you can just change cos to sine, and whenever you see cos squared, you can change it to sine if you're trying to cancel out with sine. So let me show you another example. Here is another example. So you can never be stuck, right? You can never be stuck. Of course, there's nothing to change there, but check, there is tan. So whenever you see tan, you change it to sine over cos. So let's do that. So this is going to be sine x plus cos x. This is going to be 1 plus sine x over cos x, right? Now is the addition of fractions, right? So when you have a 1 there, what you can do with the 1 is you can change it to cos over cos, right? You can actually do that. You can actually make it look like the denominator. For instance, if we have 1 plus 2 over x, we can change this 1 to look like x over x. It's another skill you should have, right? Or you can just add fractions as normal. You can say 1 is the same as 1 over 1, and you can multiply, right? If you multiply, you'll have cos, and then if you cross multiply, you have cos here, and then this is gonna be sine, right? You can do that. You can do anything, right? You can do anything. So you can change it to 1 over 1 and multiply, we'll have this, and then when you cross multiply, we will end up having this stuff, right? You can do that. Or you can actually change the 1 to look like cos x over cos x. Then you can say plus sine x over cos x, and you'll see that the denominators are the same. If the denominators are the same, then this becomes cos, right? The same denominator. Then we just add the numerator, so it becomes cos x plus sine x, and you'd see that is exactly the same thing we have there, right? If you just got a bit lost, you can just go backwards in the video and check it again and even attempt it. You can even attempt both methods, right? And if you choose to use this method, you are allowed to show it. It also appears in the memorandum. So from here, now we have a number divided by a fraction, right? So what we do is that this number is the same as, right, of course it's not a number, but it looks like a number. For instance, it looks like 2 divided by 2 over 3, you see. So remember what we do with that, the 2 is the same as 2 over 1, and then we have 2 over 3, so we just tip and times. We use that same method. So it's the same thing here. We'll say sine x plus cos x over 1, all divided by cos x plus sine x over cos x. And then you know what to do here, right? We tip and times. So when we tip and times, this becomes sine x plus cos x over 1 times. Now remember, you switch cos x, then this becomes cos x plus sine x, and then now this 2 cancels out, and then now we'll be left with 1 1, then 1 times cos is cos, 1 times 1 is 1, so we'll have cos x over 1, which is still cos x. So that's the result, that's the answer. Here is the last example. So when you look at this, remember when you see tan, have the consciousness of changing tan, right? So whenever you see tan, have the consciousness of changing tan into sine over cos. So this becomes 2 cos x over 1 plus sine x plus 2 sine x over cos x. So notice I changed it, right? These 2 can also join the numerator, right? Whenever we have a times b over c, okay, this is not a mixed fraction by all means, right? When we have times, this is the same as a b over c, right? Because it's the same as a over 1. A is the same as a over 1. So when we say a times b, it's ab. 1 times c is c, right? When we use the laws of multiplying fractions, when we see 2 times 1 over 2, for instance, this 2 is the same as 1, so 2 over 1, I mean, then when you multiply, it's 2 over 2, right? Which gives us 1. Or you can see that these 2 are the same, of course, so this 2 cancels out and it leaves 1. The answer will be the same. So what I'm trying to, the reason why I'm doing this is because when I change this, it becomes 2 times sine x over cos x, right? So this is the same as 2 over 1, right? So this becomes 2 sine x over cos x. So here we've changed it, right? Now, since the denominators are not the same, I have to multiply them. So this becomes cos x times 1 plus sine x. And then now when you multiply this stuff, is 2 cos squared x plus, I multiply this stuff, it becomes 2 sine x times 1 plus sine x. So from here we can go further. So this becomes 2 cos squared x plus 2 sine x plus 2 sine squared x. Right? So now we have reached this stage. A lot of people would get stuck here. There is many things we can do, right? So what I'm gonna do for now is I'm gonna change this into cos, right? I'm gonna change this into cos. Okay, so here we're at cos x, it was cos x, and then we're at multiplication. All right, I'm gonna change this to cos, so this will become 2 cos squared x. So if I want, I can instead change this into sine. So I'm just gonna leave it like that, and then this becomes plus 2 1 minus cos squared x. So from here now we can distribute. So I'm just gonna continue up there. So this was 2 cos squared x plus 2 sine, okay, 2 sine x. I'm just gonna rewrite exactly the same thing to avoid confusion. I'm gonna write the exact same thing that was there. So this is cos x 1 plus sine x. Okay, so from here, when we go further, when we distribute, this is 2 cos squared x plus 2 sine x. Now when we distribute, this becomes 2, then this becomes minus 2 cos squared x all over cos x plus, okay, 1 plus sine x. Let me just fix my handwriting over there. So this was cos x 1 plus sine x. So Notice these two are exactly the same, but with different signs, so they cancel out. Cos 2 cos squared minus 2 cos squared is 0, right? So what will be left is 2, it's what? It's 2 sine x plus 2 all over cos x 1 plus sine x. And notice we can't go further here, but we can do something. This is the same as this, so we can factorize it. So when we factorize, we'll have 2, and then we'll have plus 1 when we factorize the top, right? That's what we'll have. Then we'll have cos x 1 plus sine x. Then you realize that these two are the same, it's just that the order is different. When I rearrange it, it just becomes 2 1 plus sine x over cos 1 plus sine x. So these two are the same, so what happens is that they cancel out, and my resulting answer is 2 over cos x, right? I just forgot to put an x there, but I'm sure you understand that. So this is where we ended. In the next video, we deal with different exercises, several exercises. So just don't forget to subscribe to my channel and like the video. And of course, if you have got questions, just put it in the comment, right? And I'll put the link of the exercises videos or below, right?